Hey guys, welcome back to another video. Today we're going to be reacting to just happened. James Webb telescopes detects a structure that should not exist. This video was uploaded about a month ago, and you guys saw the thumbnail. It looked really interesting because the thumbnail is on my thumbnail. So hopefully the thumbnail looks good. So we're going to go ahead and click play. This video is very long, so I think we should. I think I should be fine, but we'll be good. Let's see. Go. I thought I was finna get an ad already. I was like, oh my god.
And a new window to the hidden secrets of the cosmos is opening for experts. About 6 months after the launch of the James Webb Space Telescope, the complex equipment provided us with the first overwhelming images. But this was only the prelude to an ambitious mission, at the end of which our knowledge of the universe will be lifted into completely new spheres. In addition to studying the first luminous formations and galaxies that emerged after the Big Bang, Webb's mission will also help provide the answer to one of the oldest questions in human history. Are we alone? To get to the bottom of this cosmic mystery, the $10 billion telescope will look at the atmospheres of exoplanets and check the celestial bodies for habitability. In this regard, the mysterious signal recently detected is becoming a particular focus of discussion. But what are these current headlines that tell of artificial lights on Proxima Centauri B really all about? Is it truly the technical signature of an advanced species? Or can the reports be explained in another way? Together with you, we're looking for answers today. Excited about the groundbreaking discoveries and fascinating spectacles in the universe? Then remember to subscribe to Simply Space and click the bell for regular updates on these exciting topics. Go ahead and show us with a thumbs up that we can keep you engaged with the content of our videos.
This video seems so Proxima Centauri B.
It's a question that's probably as old as humanity itself.
I don't know what that was about.
Alone in the universe? Even the countless entities that sparkle.
Wait, hold on.
Is it
personally? I don't think we are alone, but I know some people have their opinions. I don't think we're alone though.
Even possible that Earth is the only celestial body?
No, it can't be possible. Like,
although researchers have now succeeded in detecting more than 5,100 exoplanets in nearly 3,800 systems, such a sensational find is still a long ways off. Not only have we not yet been able to prove the existence of extraterrestrial life, in fact, we do not know of any planet other than Earth that can be categorized without doubt as habitable. Often the enormous distances gaping between us and the extrasolar worlds represent a substantial complication for more exact analysis. However, things are somewhat different for our closest cosmic neighbor. No other exoplanet comes as close to our terrestrial home as Proxima Centauri B. Although there are just 4.2 light years between us and this celestial body,
some light.
Its presence was only detected in the summer of 2016. Using the radial velocity method, the assumption quickly arose that the experts had encountered a cosmic twin of Earth in the course of their discovery. And it's indeed true that the exoplanet orbits its namesake host star, Proxima Centauri, within the habitable zone. As a reminder, in the world of astronomers, the habitable zone is the distance between a celestial body and its parent star, in which water can exist in a permanently liquid form. And it's well known that the presence of liquid water is a fundamental prerequisite for the development of Earth-like life. On the so-called Earth Similarity Index, Proxima Centauri B reaches a value of 0.87. As this official designation already reveals, the ESI
I don't know if that's good.
How similar another celestial body is to our Earth. But does this mean that life is possible on Proxima Centauri B, or that it has already developed there? Well,
I'm gonna say no.
According to our current state of knowledge, this question cannot be answered so easily because we simply know too little about our extrasolar neighbor. What is certain is that recent spectrographic analyses indicate that Proxima Centauri B has about 1.17 Earth masses. In addition, it can be concluded that the celestial body has a bound rotation, which means that it always turns one and the same side towards its central star. This circumstance would mean that the exoplanet is divided into two areas that differ drastically from each other. The day side, which is constantly illuminated, would therefore be significantly hotter than the opposite night side, which is plunged in constant darkness. The
Yeah.
equilibrium temperature of the planet is estimated to be minus 38 degrees Fahrenheit.
Ooh.
But even this value is anything but set in stone. If the
Yeah.
celestial body has a dense atmosphere,
I was
its
about to
surface
say no one
temperature would be
knows what it is.
significantly higher due to the natural greenhouse effect. Also,
No one knows
the
exactly what
report
it
that
is.
Proxima Centauri b could host liquid water has to be classified correctly. The orbital parameters and atmospheric composition that led to this exciting result in a simulation may not match the actual reality.
No.
Mysterious signal.
Okay.
As just mentioned, Proxima Centauri b probably divides into a scorching hot day side and a bone-chillingly cold night side.
Probably,
However, this
but
spatial division does not mean that the existence of life on the extrasolar world is categorically excluded.
no.
Between the two areas of extremes
Like-
would lie a narrow band in which
I was about to
temperatures
say-
prevail that could pave the way for the development of life. And possibly the hypothetical inhabitants, just like us, managed to evolve over time from simple single-celled
Yeah.
organisms to a highly developed species. If this is indeed the case, such a civilization would have to have left traces on its homeland, traces that we can also perceive from our terrestrial vantage point.
Yeah, but
And
at
indeed,
the same
in
time,
December 2020, a stunning discovery was announced that some
Wait.
experts interpret as just that, an artificially generated radio signal. The source of the mysterious signal could be located in the realms of Proxima Centauri.
Oh.
Originally, the researchers had dedicated themselves to the task of examining the host star for signs of flares. With
Okay.
the help of the Parkes Radio Telescope in Australia, the experts wanted to find out what effects these radiation bursts have on the surrounding planets. During the evaluation of the data, which had been collected over a period of 26 hours, Shane Smith, an intern with the SETI program, came across a conspicuous signal with a frequency of exactly 982.002 megahertz. Since then, this so-called
weird.
Breakthrough Listen Candidate 1, or BLC-1 for short, has been considered an official candidate for an artificially generated radio signal from an extraterrestrial
I
species.
mean-
But that's not all. In the same period,
I'm not gonna say there's
experts
not,
also came
but-
across a conspicuous feature in the Proxima Centauri system. The experts detected a bright, long-lasting optical flare there, which was accompanied by a series of intense, coherent radio bursts. However,
What the
fact that
heck?
BLC-1 does not currently rise
That's
above the status of
weird.
an exciting candidate is due to the fact that scientists have not yet been able to classify the background of the signal beyond doubt. To prove that BLC-1 is indeed the technical signature of an extraterrestrial species, further observations are imperative, but astronomers have not yet succeeded in detecting the signal again. As a result, another origin, such as a satellite or natural source, cannot be ruled out. Artificial lights? Let us assume that life on Proxima Centauri b has indeed succeeded in blossoming in the form of a technically advanced civilization. Against this background, it would not be far-fetched that the exoplanet's inhabitants devoted themselves over time
That's
to the
weird.
task of illuminating the pitch-black night side of their
Okay.
homeland world with artificial lights. The fact
gotta say,
that the
surely they would
discovery of
try
such a
something.
technosignature is currently repeatedly associated with the future use of the James Webb Telescope is primarily due to the comments of Avi Loeb. The Israeli physicist has been searching for new ways to uncover the presence of our previously invisible neighbors for quite some time. In doing so, the expert does not shy away from unconventional paths. Accordingly, Loeb stated in 2018 that the mysterious Oumuamua missile could actually be the solar sail of an extraterrestrial species. Together with Eliza Tabor of Stanford University, the Harvard professor published a study titled
What?
Detectability of Artificial Light on Proxima Centauri b. In it, the scientists assumed that the hypothetical
Not gonna be able to
species
tell, bro.
uses a type of light similar to our terrestrial LEDs. The result,
Ain't
if
no
the
way.
artificially illuminated night
Ain't no
side
way.
reached 5% of the brightness of the day side, Webb could prove this fact with 85% probability. The principle here
I don't
is
like-
that the more intense the artificial illumination, the higher the chances that it will be detected by our new eye in space. If the brightness of the night side were to level off at 9%, the probability of detection
Okay.
would be 95%. At first glance, an illuminance of just 5% doesn't sound like much, but unfortunately, this is a fallacy. For comparison, the artificial illumination of our blue home planet is
Okay.
only 0.001% of the reflected sun.
Ah.
In other words, this means that the artificial lights on Proxima Centauri b would have to be 500 times brighter than their terrestrial counterparts for us to recognize them as such.
We're
It's
not going to
possible
figure it
that
out.
the hypothetical inhabitants of the exoplanet have already provided us with some practical assistance in this regard. To reflect the host star's light onto the night side of the celestial body, the inhabitants could use dazzlingly bright orbital mirrors, which could also be seen by our telescopes. As exciting as the thoughts published in the study may be, we should remember that it is nothing but pure theory. At least for now,
Yeah.
it remains to be seen whether the experts' theses
There is no
might have a
way.
kernel of truth after all.
There is
Should Webb
no
one
way
day
in my lifetime that we're going to find extraterrestrial life. But I do believe it's out there because the universe is too big for there not to be something else out there. Even if Earth had a 1% chance of, life being able to live on it, that's still 1 out of 100 like planets and chances, like whichever one you want to see it as. Think about how many planets we as humans have found since we started sending telescopes into space, super telescopes into space, and looking. Think about how many we have found. There's no way we are the only ones in this world, this universe. Mathematically it doesn't make sense.
actually prove an artificial light signature on Proxima Centauri b, you can be sure that we will tell you about it here. Rohan Naidu's incredible discovery.
So I wonder if this is a bunch of other
Rohan
videos.
Naidu is a junior astronomer at the famed University of Harvard. The evening that would change everything for this young man was ordinary at first. Naidu had spent a beautiful day with his girlfriend and had just arrived home when his computer reported something incredible. He had developed a very special algorithm that he used to examine the first image published by NASA. Using mathematical formulas, the program searched for the oldest light in the data from the deep field image. Images taken of the cosmos always show light that has traveled through the vastness of space to reach us. Light that has been traveling to us for 6 billion years shows us the imprint of a world as it looked 6 billion years ago.
Yeah.
The closer an object is to the Earth, the younger the light is, and the closer to the present the existence and the position of the celestial body is. The deep field image shows us, therefore, not only celestial bodies, but represents also a view into the past. The oldest objects, or light rays on this image, are red. The somewhat younger and closer ones are orange.
White.
Then come yellow spots, and finally, blue or white ones. Naidu's algorithm looked for the red spots, and there especially for the oldest light rays. On that history-making evening in July 2022, the program reported finding a galaxy that became known as Glass Z13 and made the world of science tremble.
Ooh, why?
The impossible galaxy.
Surely it's not talking about
It
glass.
was clear that a new era would dawn with the James Webb telescope. That's what the researchers hoped for. With James Webb, they hoped to get closer to the Big Bang than ever before. The telescope's output goes back about 13.5 billion years, and the Big Bang is said to have occurred 13.8 billion years ago. It was clear that James Webb's scope couldn't quite see all the way to the Big Bang, but would have to be pretty darn close to that event. With Glass Z13, a ready and on top of it very luminous galaxy appeared, which already existed at a time in which, according to previous assumptions, when there should have been only single stars, which slowly came together to galaxies. Therefore, something was not right. Glass C13's age was estimated at 13.4 billion years. Thus, this galaxy already existed 400 years after the Big Bang. Physicists and astronomers calculated that the universe originated from a single starting point, with an event that we know today as the Big Bang. The total potential concentrated at one point began its unfolding. The ideas and models about this process were very exact. Already in the first second after the Big Bang, the four fundamental forces of strong interaction, weak interaction, electromagnetic interaction, and gravitation were formed. The universe was a hot and dense
What the
primordial
heck?
soup in which primordial particles occurred in a chaotic state. Within the first 3 minutes, however, the universe must have cooled down already so far that the primeval forms of helium and hydrogen were formed. But only after 400,000 years, the universe was cool enough to form
Yeah.
elementary particles capable of bonding. According to these models, the first stars appeared 150 million years after the Big Bang. These first stars are said
Okay.
to have been true giants of helium and hydrogen, and their lifetimes were probably very short. Such giant stars of the so-called third generation attach themselves
Okay.
sometimes to gigantic structures, which were formed by dark matter.
What
and thus,
the heck?
first protogalaxies or gas clusters are supposed to have developed. Only when heavy elements appeared in space,
Oh.
stars gained mass and thus gravitational forces. Thanks to gravity, proto-galaxies merged with
What
large
the
galaxies.
heck?
And over a period of about 1 billion years, the globular clusters, spiral arm galaxies, or disk galaxies may have formed galaxies as we know them today. With
What
the
the
discovery
heck?
of glass C13, this model was abruptly destroyed because a galaxy of this mass, this order, and luminosity should not have existed 400 million years after the Big Bang. Initially, there was still hope that Naidu's algorithm was wrong, but not all researchers hoped for an error, because the Big Bang theory has meanwhile also many opponents. More and more indications, or even proof, speak to the fact that our
Yeah.
universe is structured in truth completely differently, and also its beginnings were different than assumed so far. Shortly after Naidu's discovery,
There's a god.
new galaxies appeared almost daily, and they became older and older. Last C13 was therefore not an isolated case, but only one of many. Proponents of the Big Bang theory have experienced 1 or 2 sleepless nights since last summer. Everything they had believed in so far could now prove to be wrong.
Yeah.
The mystery of dark matter.
Oh, this is gonna be a good one.
Reconstructions of the beginning of the cosmos are based, to a large extent, on
This is gonna be a
realizations
good
of
one. This
exotic
is gonna be a
physics.
great one.
This is precisely where some researchers see the problem. This branch of astrophysics deals with dark matter, or negative matter, and from exactly these forces, we know up to now only very little. About the interactions and feedback between starlight,
Oh.
gas, and dust, there were so far more theories and hardly founded knowledge. Somehow, the assumptions and calculations fit together until James Webb came along. Actually, this branch of physics also hoped to finally learn more about the phenomena underlying the Big Bang
okay.
and the beginnings of the universe by looking through the telescope to the cosmic dawn. Now these researchers had to realize that James Webb had provided them with quite different food for thought. In short, the results mean that the Big Bang never existed at all, that it took place at a different time than previously assumed, or that the processes of the beginning of the universe took place completely differently than scientists imagined and calculated so far. Soon, still another galaxy appeared at the edge of the universe known so far, which turned previous assumptions completely on their head. Sears 1749 became known as the Schrödinger galaxy. This galaxy is also one of the oldest and not a Big Bang conformed galaxy. But Sears 1749 has another special feature. The galaxy is in a direct cosmic environment in which the surrounding celestial bodies show an age which does not fit to Sears 1749. This galaxy had already existed 200 million years after the supposed Big Bang, and seems to be somehow also from another time. Are red light shift errors to blame?
No.
The appearance of the enigmatic Schrödinger's galaxy, which got its nickname from the quantum experiment, Schrödinger's cat, cast doubt on the accuracy of previous measurement methods. At present, the measuring methods are checked worldwide, but so far, it looks as if the measuring methods are correct, and in the meantime, even older galaxies have appeared. Redshift is the shift of spectral lines to longer wavelengths as an object moves farther away. In astronomy, the redshift is denoted by a dimensionless quantity z. Z equals 0 corresponds to the present. If the value increases for objects in deep space, their distance and our look-back time also increase. Hubble was able to find a single galaxy with a redshift of 11. Redshift 11 tells us that this galaxy is 13.4 billion years old. The Big Bang is said to have occurred 13.8 billion years ago. For a long time, the galaxy discovered by Hubble was considered the oldest, and now Webb brings to light dozens of other and even older galaxies. The oldest galaxies discovered in the meantime have incredible values of 20 Z.
What
Long-term
the heck?
observations with the Atacama Large Millimeter Array or the ALMA telescope in Chile could confirm
Okay.
Webb's data in the meantime. Currently, astronomers are desperately trying to fit Webb's observations into various cosmological models. Only time will tell
Okay.
if they will succeed. The findings are still too recent to draw definite conclusions. It all began with a mistake.
What?
The first image of this type actually came about through a mistake in 1995. U.S. astronomer Robert Williams had a
Whoa.
Hubble contingent that year that he could use for himself and his work. The
Okay.
astronomer decided to point the telescope at a comparatively empty spot in the constellation of the Big Dipper. That Hubble's observing time was scarce, expensive, and in hot demand. Researchers worldwide shook their heads at how Williams let a quasi-empty space in the cosmos be studied by the world's most expensive and best telescope.
Okay.
Hubble took 10 consecutive days of images. Experts predicted that this observation would reveal at best a handful of faint galaxies, and Williams was on the verge of losing his job because of his extravagant request. But then, the miracle happened. Due to the lack of luminous stars and galaxies in the foreground,
Okay.
light from much older stars and galaxies came through in the image. The Hubble Deep Field showed that the supposedly empty spot was filled with thousands of galaxies up to 12 billion years old. For the first time,
Wow.
researchers saw so far into space, and a whole new way of observing the cosmos was born. It was then that
What the
researchers
heck?
came up with the idea of constructing a new telescope. With a new space telescope, they wanted to look even deeper into space, and even further back in time. Well, that has been achieved today, less than 30 years later, and we are only at the beginning of the James Webb mission. So it will remain exciting,
Yeah.
and we can be curious what secrets the telescope will still reveal. The view to the edge of space.
Ooh.
One thing is certain, James Webb looks deeper into the universe than any other telescope to date, thanks to a 21-foot mirror with 18 honeycomb-shaped segments. James Webb can capture light that has been traveling to us for more than 13 billion years. The 69 by 46-foot telescope is packed with high-tech, state-of-the-art instrumentation. According to NASA, the telescope's infrared sensors are so sensitive to infrared light that even the slight warmth of a bumblebee at the distance of the moon can be detected. As a result,
What the
this
heck?
telescope will eclipse anything that has been technically possible. James Webb is considered 100 times more sensitive and powerful than the Hubble Space Telescope. The mission motto could be sharper,
What
deeper,
the?
higher, and in doing so, the technology delivers vastly improved color imaging compared to Hubble. James Webb is not just
Yeah.
a telescope, but something like a gigantic time machine. Our universe is said to be about 14 billion years old, and Webb can safely capture light that has been traveling to us for 13.5 billion years. Thus, this giant
What the
looks
heck?
to the edge of time. Although Hubble has already been a revolutionizer in space exploration, the old telescope couldn't look quite as deep, and the images Hubble could provide of the oldest galaxies were
Yeah.
comparatively fuzzy and blurry. Unlike Hubble, the new telescope is also located much deeper in space. Hubble, to date, is located at a distance of 342 miles. James Webb, on the other hand, is positioned a full 900,000 miles from Earth in space. That is more than
What
4 times as
the
far
heck?
away as the moon. For NASA and all the nations involved in
What
building the
the?
telescope, this represents a significant risk. Hubble has had to be repaired and upgraded 5 times during its 30 years of operation. To do this, NASA space shuttle missions flew virtually to our cosmic front door and fixed it. James Webb is too far away to fly to. Repair missions could be a challenge to the development of modern space flight. NASA long ago discontinued its space shuttle program due to
about to
technical
say.
defects. The only spacecraft currently carrying humans
SpaceX.
into space are the Dragon shuttles from SpaceX and Elon Musk. Of course, if SpaceX
course they
flies
are.
humans to Mars as planned, starting in the 2030s, they could stop by James Webb. and change a few
2030?
light years. We now look at what James Webb has shocked the world of science with. The oldest objects. Even on the first picture NASA presented to the world public, things were to be seen
What?
which should not exist at all. The deep field picture shows in reddish coloring the oldest galaxies of the universe known so far. Here, first investigations
That's crazy.
provided for an
This is
unexpected
actually
sensation because the
really
oldest
interesting.
galaxies are to all
It's a long
appearances
video,
much
but
older
it's
than seen
interesting
so
as
far.
hell.
Scientists must now come to
I don't even know
terms
like
with
to
the
say
fact
for
that
half of the
already
stuff.
massive and luminous galaxies already existed 200 million years after the Big Bang. At the moment, international expert teams are examining the authenticity of these findings and looking at whether there could have been perhaps an error with the past determination of distances and the age of galaxies. If the accuracy of the measurement methods is confirmed, all theories about the Big Bang will have to be rewritten, and researchers may soon have to find new explanations for the beginning of the universe and time. At the top
What
of the
the
list
heck?
of the probably oldest galaxies are currently the galaxy Glass Z13 with an age of 13.5 billion years, and the galaxy Sears 93316, which could be even a tad older. Remember, the Big Bang should be about 13.7 billion years ago, and after the Big Bang, there was supposedly nothing for a very long time. But Webb's pictures show something else. Are there exoplanets with
Well,
life?
obviously they're gonna be
The
planets.
second sensation that
Exoplanets,
NASA
actually?
published was only a few days ago. On
No.
January 11th, the space agency announced observational data collected as early as August 2022. Detecting exoplanets is one of the telescope's major tasks. Like no other before it, James Webb can sense tiny planets at incredible distances
Yeah.
as they pass in front of their stars. Or the telescope analyzes minute changes in the star's light spectrum to determine the presence of planets. On top of all this, the telescope is equipped
Dang.
with instruments that, for the first time, allow it to make the finest measurements in the vicinity of exoplanets. The determination of a planet's composition and any atmosphere can thus be examined in greater detail. The first planet analyzed in this way was LHS 475b, a rocky Earth-sized exoplanet orbiting a red dwarf star about 41 light-years away in the constellation Octans. The planet
Ridiculous,
is much
bro.
closer to its star than Earth is to it, and a year lasts only 2 days on LHS 475b. By analyzing the transmission
What
spectrum,
the?
scientists are now trying to determine what is present in the planet's atmosphere. In doing so, James Webb proved that it can easily detect a whole range of molecules. So far, the data have not been sufficiently analyzed to say for sure that LHS
What?
475b has an atmosphere and possibly the conditions for life. But again, the first successful measurement was only the starting point, and we can look forward to more sensational results. The search for the edge of the universe. Does the universe have a beginning, an end, and boundaries? James Webb is intended to do no less than finally
No.
clarify these essential
No.
questions
There
of
is not an
mankind.
edge.
In practical terms, the telescope can look back in time 13.5 billion years. That should be to shortly after the Big Bang. It remains to be seen
Technically,
whether
yes,
James Webb's
but
scope
no.
can look back even further than previously thought. As we've already told you, the telescope has already turned the world of science upside down with the first images of extremely old galaxies. If researchers have found evidence of the Big Bang thanks to James Webb, at least the starting point would have been confirmed. But this is not so, and also no
No.
hints were found on boundaries of the universe, which existed shortly after the Big Bang. In this context, of course, the question immediately arises whether James Webb can theoretically look to the edge of the currently existing universe. However, this question must be answered quite clearly with no. James Webb can only capture light and make sources visible. The light that hits the telescope's mirrors has been traveling in the cosmos for a different amount of time
What
before
the
it
heck?
reaches us. The image that James Webb records thanks to the light always shows the position of the light
Oh my
where it was at
God.
the moment it was emitted. Galaxies whose light
Oh
reaches
my.
us after 13 billion years very probably do not exist today. Even the light of our
No.
nearest stellar neighbors in the Centauri system takes about 4 years to reach us.
Yeah.
We then see the stars as they looked 4 years ago.
Yeah, so-
since we have practically zero possibilities to look from Earth into the existing universe at the
Technically-
moment,
technically we
see
can't
to an
see-
edge either. As
There we
we
go.
know today, not
Technically,
only
nothing we
galaxies
see
move in an expanding way
anywhere
through space, but the
is
whole space expands.
current
the starting
time.
point was supposedly the Big Bang, which is now under scrutiny. A
Like,
previously
if
unexplained
the,
factor
I think
in
it's
the
if
overall
the
structure
sun
of
was
the
to like
universe and
collapse,
its expansion
our
is
sun was to
black or
collapse,
dark matter.
we
Here,
wouldn't
too,
find out for
James
13
Webb
minutes
is
till after it
expected
happened.
to provide new insights. However,
I mean, we
the
might
first
feel
measurements
something,
on
but
this are still pending.
we're not
The
going to
results
notice
could be the
anything till
much-needed
13
pieces
minutes
of the
after.
puzzle of the overall cosmic picture, or once again terrify the world of science. Dark matter is very likely an essential building block of the universe. It's the original ground of a not less mysterious network, which forms the basic structures of the universe. That there is dark matter is clear. It only escapes all physical rules known up to now, and it's exactly this that provides for sleepless nights for scientists. What if everything astronomers and physicists thought they knew about the cosmos is wrong? If the telescope
What
continues
the
to
heck?
deliver results that do not fit the previous theories, we will be able to experience in the coming months and years how the history of the origin of the universe will have to be completely rewritten.
What the?
What do we really know about the cosmos?
Nothing. According to this video,
We know
nothing.
for sure at the moment is the size of the universe known so far. This is the part of the cosmos that we can observe with telescopes. However, we currently have absolutely no way of estimating how large the universe actually is. James Webb's observation radius is 13.5 billion light years. The total size of the known cosmos is about 28.5 gigaparsecs. Parsec is a so-called astronomical unit, shortened as AE, for cosmic distance specifications. One astronomical unit corresponds to the distance between Sun and Earth, or about 90,000 million miles. One parsec corresponds to 3.6 light years, or 5,880 million miles. So 28.5 gigaparsecs would put us at about 58 billion miles, and we humans can hardly imagine that spatially. So far, researchers assume that we on Earth can only see light up to a distance of 16 billion years. Researchers call this line the event horizon. What happened before that, we humans will probably never know, unless our technologies make dramatic progress. But researchers are confident that they can reconstruct events thanks to computer simulations. To do so, constants within known space must be available, and that's what James Webb is finally expected to provide. At this point, many questions remain unanswered. Will we finally find traces of life on other planets?
I
Will
hope we
unravel
find
the
traces
mystery
of life
black
somewhere.
matter? And will we find the edge of the universe?
No,
Tell us
we'll never
what you
find the
think
edge of the
about these
universe.
questions. Did you firmly believe in the Big Bang Theory and are now shocked? Or
No.
are you one of the few people who can actually imagine an infinite universe? Revolutionary insights. In
No.
media coverage, the James Webb Telescope is often dubbed a replacement for Hubble. But if the views of NASA's leading experts are anything to go by, the term scientific successor is far more accurate. After all, many of the research goals that Webb is currently addressing and will address in future years were inspired and made possible in the first place by the results delivered by Hubble. In order to add to the revolutionary body of knowledge that Hubble's use has revealed to us, it seemed only logical to develop a successor specifically designed for infrared astronomy. This is because the light of far distant, and thus also early areas of the cosmos, is shifted into the near-infrared due to the cosmological red shift. With its unprecedented technical precision, the James Webb Telescope allows us to catch glimpses of those first luminous objects and galaxies that emerged after the birth of the universe and the so-called Dark Ages. Furthermore, the $10 billion instrument looks deeper than ever into the mysterious world of stellar cradles, analyzing the chemical and atmospheric compositions of extrasolar planets.
Oh my
in
gosh.
unprecedented
There's no reason to be doing all that.
A look at the following images shows the breathtaking developments that telescope-based space exploration has already made in the past. Although the images produced by WISE, Spitzer, and Webb depict one and the same region of the sky, they could not be more different in terms of quality and detail. While the WISE image shows nothing more than a blurry collection of coarse points of light, we can at least make out something like individual structures on the Spitzer image. What Webb captured for us finally shows us the sky in its true glory. On the much sharper image, we see countless sparkling shapes and complex cloud structures that we could not even guess at in the previous images. A star cradle in comparison. A look at the Carina Nebula also shows what the often cited dawn of a new research chapter is all about visually. Located in the constellation keel of the ship, and about 9,000 light years away from us, the colossal structure has a reach of up to 300 light years. In detail, the Carina
Okay.
Nebula
Okay.
embodies one of the most significant stellar
Honestly,
cradles in the Milky Way, and yet a brief comparison between the Hubble and Webb images reveals how
Breakthrough
many
findings,
sparkling
looking
secrets
back
once
to-
lay hidden behind the dense clouds of dust and gas. In fact, many of the objects that Webb captured in the infrared were completely invisible in the previous images. How a star
there's
is
still
formed.
20 minutes in this video. Oh
Speaking
my
of cosmic
god.
star cradles, it's
This
worth
video
taking a
is
look at the
so
stunning
long,
image
bro.
Webb made of a protostar in dark cloud L1527. Basically, stars are born when a cloud of dust and gas collapses under the weight of its own gravity. As a result, the matter in the center is compressed to such an extent that the molecular hydrogen decays to atoms. The protostar that is created in the course of this process already glows, but it still has too little mass to ignite the fusion of hydrogen.
Oh my
This is
god.
not possible until the stellar baby accretes enough additional material and becomes sufficiently dense. This is a development that is currently still in full swing in the protostar, which is about 100,000 years old. In detail, this can be seen in the form of a bright spot slumbering in the center of the hourglass-shaped structure.
What
Consisting
the heck?
of gas and dust, the stellar cocoon reveals to us in infrared light where particles and gases ejected from the protostar collide with the surrounding material. Just like human babies, the stellar infant burps from time
What?
to time. These present themselves as bubble-like objects in the upper part of the hourglass and are the result of shock fronts of hot hydrogen gas. Breakthrough in planetary research.
What?
It's probably the central question of our time. Are we alone in the universe? Anyone who takes a closer look at this exciting topic is inevitably confronted with another question. Is
No.
Earth the only celestial
No.
body in the cosmos that harbors life, or at least provides the necessary conditions for it? To study an
No.
exoplanet in terms of its potential habitability, it is essential to decipher the exact nature of its atmosphere. Only in this way is it possible for us to make statements about the friendliness or hostility to life forms on other celestial bodies. And indeed, the James Webb Telescope should now reach an absolute milestone in this respect with the help of the collected spectral data.
Oh,
the
I feel like
experts
I've seen
were
the
able to
same
analyze
clips
the
over and
atmosphere
over again.
more precisely than ever before. This was an astronomical sensation that Webb's predecessors had not
Oh
been
my
able
God.
to achieve due to their technical limitations. This is now a thing of the past, thanks to Webb's near-spec spectrograph and the nearest instrument. As soon as a planet apparently passes its host star, the atoms and molecules of the atmosphere perpetuate telltale absorption lines in the light spectrum. The gas giant WASP-39b, about 700 light-years away, shows us how revealing the investigation of such transit signatures can be, since this planetary colossus exceeds the size of the mighty Jupiter by a factor of 1.3. The decoding of its gas envelope proved to be particularly revealing. In addition to the previously recorded carbon dioxide and water deposits, Webb's instruments also revealed the presence of sodium, potassium, and carbon monoxide.
What?
In the same breath, it was revealed that the planet's atmosphere does not appear to contain methane, a fact in which WASP-39b differs significantly from some of the gas giants in our home system. Particularly interesting, in the acquired spectra, the experts detected an absorption line that initially could not be placed in a known context. The comparison with models then provided the insight that we are dealing here with a trace of a molecule that has never before been observed on an exoplanet, sulfur dioxide.
Sulfur
Findings and
dioxide, what the heck?
This conclusion is especially significant because sulfur is commonly found on gas giants, mainly as hydrogen sulfide, and because it can give us clues about the extrasolar world's formation history. Accordingly, the surprisingly high sulfur dioxide content, combined with the ratios of other elements to oxygen, suggests that the atmosphere of WASP-39b contains up to 30 times more heavy elements than the Sun. The low volatile element content should also not be ignored here. From our current models, gas giants are formed by the collapse of dense gas assemblies in protoplanetary disks. The high proportion of light elements serves as an indication of this formation background. However, the matter is somewhat different in the case of enrichment with solids. As a result of the obtained information, therefore, it's concluded that the extrasolar gas planet was probably formed in a similar way as Jupiter and Saturn. Initially, a solid planetary nucleus formed before massive amounts of gas were accreted as a result of the accreting gravity. The data provided
I'm
by Webb
tired.
mark
This
nothing
video is
less
making
than a
me
major
feel like
turning point
so
in exoplanet
small
research. Accordingly,
and
they provide
dumb.
us with completely new insights into the
I don't know,
evolution, chemistry,
this video
and
makes me
physics
feel
of alien
stupid. Like, I'm not
cosmic
gonna lie.
worlds,
I
and
thought I
will
was
possibly
smart, and then I
help to
watch
prove
these
the
videos, and then I
existence
feel
of
dumb.
extraterrestrial
Like,
life in the future.
I don't know.
Looking
It's just,
back,
it's crazy.
as mentioned earlier,
Crazy how smart
however,
some people are on this
deciphering
world.
extrasolar planets
On this planet.
is just one of several exciting research goals Webb has been given on its
Looks like a
journey
giant
through
Ethernet
space.
port on the front of
question
it.
the origins and characteristics of the universe's first stars and galaxies has also kept scientists spellbound for some time. The first images already confirm that Webb achieves the task with flying colors. Researchers identified several formations that could be the oldest known galaxies of all. With a redshift of 13.1, the galaxy candidate, Glass Z13, might have seen the cosmic light of day 300 million years after the Big Bang. The problem is that detailed spectral data are essential to verify the age and
We're not
nature
gonna.
of galactic
I don't think a
candidates.
galaxy
In fact,
will ever
supposedly
last
ancient galaxies
that
may
long.
turn out to be much younger stellar assemblages in analysis. While we lack the relevant data in the past, they have now been collected and revealed for the first time in Webb's history. The Space Telescope provided the spectral data of 250 old galaxies. The result? 4 of the studied constructs have a particularly high redshift. The oldest of all investigated galaxies has the scientific designation JADES GS Z13-O, and it existed 13.5 billion years
At
ago.
least.
In addition, some
Or
characteristics
many,
of the
that many
early
years ago.
galaxies
It could
have
still
already been
exist. That's the thing.
determined. They were relatively
With these
small
so
assemblies.
stuff like this could
whose
still
star
exist,
formation
but
rate
we
was
won't
about
ever
1
know
to 2 solar
because
masses per
of
year.
how long
But
it takes
also in
light to
this
travel
case,
here.
It has to be said that the unveiling of this early universe has just begun.
Oh
The
my
experts have
God,
already
bro.
discovered several more primordial galaxy candidates that need to be analyzed spectroscopically in the near future. James Webb's search for the beginnings of space. The mission of the largest and most expensive space telescope
I want to see.
ever
So,
has several goals.
no offense to this video, but it's getting very repetitive. I want to see this section right here that has discovery of Sears. I don't know, Sears.
The discovery of Sears 1749.
Sears. Okay, I want to see. I want to watch
Since
this part because this part has the
2015,
most
the
replayed
record
video.
holder in the hunt for the oldest galaxies in the universe has been the galaxy GNZ11, discovered by Hubble. GNZ11 is about 13.4 billion years old
Okay.
and has only 4%
Okay.
of the size of the Milky Way. According to the Big
God.
Bang Theory, GNZ11 would have formed about 400 million years after the Big Bang. The age of the galaxies is given by the redshift value, which is
Okay.
abbreviated in physics to a small z. The redshift has to do with the propagation of light in space. As you saw in the deep field image, certain filtering techniques used by the James Webb cameras make nearby objects appear bright and distant ones appear reddish. To find out more details about a reddish and distant galaxy, researchers analyze
Stuff
certain
like
patterns
this,
and
you just
shifts
zoom
the
in
color
and
light
randomly
spectrum.
look for
These
random
patterns
pixels
allow
of red.
conclusions to be drawn about how bright, old, and distant a galaxy is from us. The larger the redshift, the greater the distance of the object, and the earlier the object was present in the cosmos. The galaxy GNZ11 reached a value of 11.1 Z. Hubble could not
Alright.
see further with its measuring instruments. All the more pleasing to the world of science that James Webb can now theoretically detect galaxies with values up to 20 Z. That such galaxies exist at all was doubted by many astronomers. Previously accepted theories assumed that several million years after the Big Bang, there was not much more in space than dust, gases, and motion. When the first stars and galaxies formed was still a mystery, but it's precisely this fact that can now be better illuminated and seems to call into question everything previously assumed. In 2015, the discovery of GNZ11 had already triggered a small revolution.
Okay.
Because this galaxy already existed 400 million years after the Big Bang, and researchers had not considered that possible up to this time. The astronomers were all the more surprised now that the James Webb picture shows many galaxies with redshift values of 13 or 14Z and more.
God.
It was thus clear that James Webb would fully meet all expectations and provide astronomers with revolutionary data. But even before the experts could start studying the newly discovered galaxies, astronomers from the University of Edinburgh in Scotland topped everything. They announced that they had found a galaxy with the incredible value of 17Z. The value
Whoa, wait,
would mean
what?
that this galaxy had a redshift of 17Z or more. The value would mean that this galaxy already existed 220 million years after the Big Bang. The galaxy, which first got the designation Sears 93316,
What the
and later the slightly different name Sears 1749, shows in addition to its unusual age, further peculiarities which do not fit into the old ideas of science.
Okay.
Large mass. Besides the unusual age, Sears 1749 has a huge mass, which means that there are a lot of stars in the galaxy.
Okay.
So the oldest galaxy in the universe is anything but a small, puny cluster of stars that might have formed shortly after the Big
Okay.
Bang. With 5 billion solar masses, Sears 1749 is about 5 times heavier and more massive than our Milky Way, and much larger
What
than
the
any
heck?
other galaxy in its immediate vicinity. Extreme
All right.
brightness.
No, we're done. This makes my brain hurt. All right, we're done. Yeah. Thank you guys so much for watching. I hope you all enjoyed. If you did, make sure to like and subscribe. I feel dumb. Peace out.